I want to remind you of kind of two very important formulas from Algebra 1 for involving lines. The first is everyone's favorite slope-intercept form of a line. Mx plus b, where m is the slope and b is called the y-intercept. So a review from Algebra 1 and from your days in middle school. You spend months and months on this, we're going to spend a day. There's another less widely remembered form from algebra students, which is called the standard form of a line. The standard form of a line is simply this, where A, B, and C are real numbers. Just another way to rearrange the terms of a line. Major differences, this is always y equals is slope-intercept form. If you rearrange your terms algebraically so you get y equals in your slope-intercept form. If you rearrange your terms so that you have the variables on one side and the constants on another, then you have your equation what's called standard form. They're both useful. Just slope-intercept is kind of more widely used. Regardless of whichever form you use, side note, there are other forms of lines as well, like point slope form you may recall back from the day, and so forth, but these are two we're going to focus on. Regardless of what form you have, if you want to write the equation of a line, you better either have or be able to calculate these two things. You better know a point, at least one point on the line. You better know at least one point on the line. And you better also know or be able to calculate the slope of our line. If you have those two things, you can write the equation of a line every time with relative ease. For example, here are two lines that I've graphed. Let's find the slopes. Let's find the equations of these lines. Okay? So to do so, we need to find at least one point and to find or calculate the slope of this line. Well, let's find a couple places where this line definitely crosses an intersection. So like I see this point right here, -1, -3. And another place where it definitely crosses at an intersection is
I don't see 2, 2.
It's debatable. We'll get different answers. It's kind of vague. I think 4, 4 is the best one. 4, 4 definitely. I could say beyond a reasonable doubt crosses at 4, 4. There may be other places that looks kind of close, but I think at 4, 4 is the least ambiguous one. I should say. So if I want to write the equation of a line, I need to have each of these. I definitely have a point. In fact, I have 2 points, which is fine. But I need to know what the slope is. Well, I didn't tell you the slope, but you should be able to calculate the slope. You can either count rise over run from here to here, since it's graphed, or you can use the slope formula, whichever one you so choose. We could use the slope formula. Sounds good. 4 minus -3 over 4 minus -1, which gives you 7/5. Would be our slope. If I want to write the equation of this line, we can use the slope-intercept form to figure out what the value of b is, what the y-intercept is. Well, since we know the formula y equals mx plus b, you know a point. We know an x comma y. We know an x and a y are. You've just calculated what slope is or what m is. So what we know is 3 of the 4 things in this equation, y equals mx plus b. Let's plug in the three things we know and figure out what b is. So y is -3 equals slope 7/5 times x, which is -1, plus b, and figure out. 7/5, -7/5 is the same as -1.4. -3 plus 1.4 is -1.6. Is b. It's also the same as, you could have rewritten this as -15/5 and added -15/5 plus 7/5, which is still -8/5 or -1.6. If you know b, you know the slope, then we can write it in slope-intercept form as y equals slope times x plus the y-intercept plus -1.6 or minus 1.6. Second one, let's find a couple points. I'm definitely going to choose this one, 0, 3, and then pick any other ones. How about 3, 2? Or how about, you could have chosen this one, -3, 4. There's some points, whatever. Let's find the slope. If it's graphed, let's make life a little bit easier. Let's go rise over run. Down 1 to the right 3. The slope is -1/3. What's the y-intercept? Do we need to plug in our formula and calculate it? Why not? Because you know where it crosses the y-axis at 3. It crosses the y-axis at 3, therefore the y-intercept is 3. You could use the formula, plug in, and solve, or you could use the graph and do less work. And get y is equal to -1/3 of x plus 3. If you don't have a graph, the process doesn't change. Still, find yourself a point, find yourself the slope, and run with it. First example, I give you 2 points. Even if they're not graphic, still tell you 2 points. You can pick one of them. I like to go with smaller numbers. The slope we don't have, but you can calculate it. The slope should be what? 7 minus 6 over 4 minus 2, or 1/2. Use the point slope, or use the, slope-intercept form. Y is equal to mx plus b, y for y, x for x, slope for slope. 6 equals 1/2 times 2 plus b, 1/2 times 2 is 1. B is therefore 5. Slope, y-intercept, y equals 1/2 of x plus 5. Since this line has a slope of 2, then our line has a slope of 2 because they're parallel. What's a point on our line? -1, 1. Okay, you got your slope and a point. Crank it out. 1 equals 2 times -1 plus b. Y equals mx plus b. 1 equals -2 plus b. B equals 3. B is 3, slope is 2. Y equals 2x plus 3. Let's play a similar game but with perpendicular lines this time. I still need to have a point and the slope of the line I want to graph, or write the equation of. Point on the line I want to write the equation of is given, 2, 3. What's the slope of the line I want to graph, or I want to write the equation of? Page? 1/2. If our original slope is -2, and we have perpendicular lines, -2 or -2/1, therefore my slope should be the opposite reciprocal. Therefore the slope of my line is 1/2. And again, turn away, same game. 3 equals 1/2 of 2 plus b. b equals 2. 1/2 times 2 is 1. 3 minus 1 is 2. Therefore, my equation is y equals 1/2 of x.
Is that also a coincidence that they're both 2?
It is also 100% coincidence
Is that where they
that these came up, that those two happen to be the same.
Is that where they meet for like their
Let's shift gears slightly. So let's shift algebra gears just a little bit. What if it, instead of giving you the equations in slope-intercept form, I give them to you in standard form? Well, you have two strategies. One would involve more algebra than the other. The one that's more work would be rewriting those equations in slope-intercept form. So solve those equations for y. Would be one strategy. We're not going to do that. Another strategy, the hotel booked apparently. If we're going to graph in standard, in what's called standard form, it's not a bad idea to use the following strategy, which is to graph using the intercepts. So let's draw some axes in here first. We're going to graph using the intercepts. I'm going to draw my axes. This is my y-axis and my x-axis. What do you know about the values of y when you're on this nice x-axis, nice horizontal axis? What is every y equal to if you're sitting on the x-axis? 0. On the x-axis, y is 0. Similarly, when you're on the y-axis, what's the value of x?
0.
0. Well, if I want to graph using the intercepts, I can graph, if I could find the points where my line crosses these two lines, that'll give me 2 points and I can just draw a line through. Well, the point where the first line crosses the x-axis has to be when the value of y is 0. So if you were to say plug in 0 for y and figure out what x is, that would tell you the x-intercept. So we'll start by finding the x-intercept. That means when y is 0, we'll plug in 0 for y, and solve, x is 2. So when y is 0, x is 2, or I get this point, I get the following intercept on my graph. Let's repeat with the y-intercept. It crosses the y-axis when x is 0. So let's put 0 in for x. And solve. Y is -6. So I'll put a dot at x is 0, y is -6. 1, 2, 3, 4, 5, -6. There we go. Line 1. Two, 0, -0, -6. Repeat this game for number 2. X-intercept is when y is 0. X is 4. The y-intercept is when x is 0. Or quickly substituting and rearranging. When x is 4, when the y-intercept is, excuse me, x-intercept is when x is 4. The y-intercept is when y is negative 4. So if I plot those 2 points, I'll do it in blue. 1, 2, 3, 4. Down 1, 2, 3, 4. Your line 2. Plot the well. Does anyone remember what the general form of what if a line is horizontal, what its equation has to look like, what it's forced into looking like?
X equals y plus b. For x equals b. For y,
Yeah, you can
y
see that.
equals b.
Horizontal
Oh
lines.
no, I'm done.
I like using the letter C, but it's basically the same thing. C is a constant or any real number. So y equals with no variable, with no x's. Conversely, vertical lines are when x is equal to a real number. If you can rewrite your equation such that it's in this form, it's either y equals a number or x equals a number, then you get a horizontal or a vertical line. Which makes graphing them pretty quick. If I were to say, draw in, say, a set of axes, and ask you to graph the line y equals 3, say horizontal line through 3. So like horizontal line through 3. Horizontal line through 3. X is 5 is a vertical line through 5. 1, 2, 3, 4, 5. Be the line x equals 5. And you could rearrange these and finish it off. Rearrange these so it's in x or y equals form. So how about add 6 to both sides? Graph the line x equals 4. You graph the line y equals. Subtract 2 from both sides. Graph the line y equals -3. Vertical line through 4, horizontal line through -3.